Hello again everyone, welcome back to ptet.chemistry channel. So this is a continuation of this topical MCQ on section B of 10.1, which is just my classification for introductory organic chemistry. It covers things like naming, the type of formula you would draw, structural, skeletal, display, as well as more commonly on isomerism, which are probably the majority of the type of reactions, the type of questions you will see for this particular topic 10.1. right? So let's get started. So they say we have 2,2-dimethyl pentane. So pentane refers to 5 carbon. That is the longest carbon chain. As you would know, if you know how to name, I'm going to start by drawing skeletal because that is what I'm good at, and that's what I like to teach students to think, because that's the fastest. Okay, you don't draw display for your MCQ, yeah, okay, because trust me, you will struggle. All right, it's a dimethyl, so you have 2 times, so you have 2 times CH3, and both of them is at position 2. All right, so when you write the structural formula, well, actually instead of writing it, since all of it has been written out, what I'll do is I will convert or draw. Okay, so number 2 shows me that I have CH3, 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 C, CH2, CH2, CH3. So that is number 2, CH3, 3 of them. This carbon is this carbon, CH2, CH2, CH3. Alright, now I'm going to work out the longest carbon chain, 1, 2, 3, 4, 5. I don't start 1, 2, 3, 4, 5 because that will mean my branch is at position 4. That is not the way you will name it. So again, 5 carbon chain, 2 methyl at position 2, so 2 is actually a way of representing it. All right, so rather than me writing out structural formula for this, since I'm already provided, I'll just draw them out. Okay, number 1, CH3, CH3, CH. So this is your CH3 twice, this is your carbon bonded to 3 other carbons, so there's a hydrogen there, CH, CH2, CH, like that. I can tell number 1 is wrong because I can see the methyl group are no longer there. So CH3 twice, CH, CH2, CH, hang on, what? CH3 twice, CH, CH2, CH. So my methyl group should have been there. I've added 1 extra carbon. Let's check again. CH3 twice, CH, CH2, CH, CH3 twice. Alright. So let's work out our longest chain carbon. 1, 2, 3, 4, 5. This is a 2,4-dimethyl pentane. Okay, this is wrong. 2 is correct, 1 is wrong. You are left with C, which is option 2 and 3 are correct. As you will know with this type of section B kind of MCQ, I can show you 3 is correct. If I draw CH3, CH2, CH2, C, CH3, CH2, CH2, C, and then 3 methyl group. Alright. Number the longest chain carbon. 1, 2, 3, 4, 5. Again, you have the branch group there, just like you have the branch group there, just like you have the branch group there. Okay. So that's why 3 is also correct. But without even checking it, 2 is correct. Then I check 1. 1 is incorrect. I'm left with 1 option. Alright. Moving to the next question. So which statements are correct? Alright. So number 2, it says it has geometric isomers. So geometric isomer refer to cis or trans. If I draw skeletal, because I'm more familiar with skeletal, plus like the more skeletal I draw, the better I'll get at it. Okay. So that is your CH3, there's your CH3, CC double bond, there's a CH3 there, there's a CH, because carbon only form 3 bonds here, there's a CH, this is a CH3, this is a CH2, CH2, CH3, alright? So I hope that makes sense there. I mean, the more you practice drawing skeletal, the better you get at it. If you don't start practicing, you will not get better at it, alright? So it does have cis and trans because I can draw this one. So this is the trans, this is the cis. That is your important group because between this and this one has the higher molecular mass, this one is got the high priority group between this and this. Alright, so high priority group are on the same side. This is the cis actually. There's the cis. Okay, so if your high priority groups are on the other side, okay, you don't really deal much with high priority groups, so that's why they don't ask you to name cis and trans. But if you look back in your AS chemistry, how you would name whether something is cis or trans in cases like this, it's not just the CH3 and the CH3, it's not as simple as that, yeah, okay. Well, not that you need to. I've shown you that this one is actually the cis, and they have cis and trans. Regardless whether you get them wrong or not, you can tell they are not the same because you cannot rotate freely about double bond. Okay, check for number 1. All the carbon atoms, they are not saying the hydrogen, they're saying carbon atoms. All right, so we know this is sp3, 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 sp3 hybrid. Only this is our sp2. If I show you which one are lying on the same plane, yeah, from the skeletal formula, actually I can also tell that it's got an optically active center there. So if I use a different color, that carbon is bonded to a 1 carbon, there is 2 carbon, that is something with alkene, and there's a hydrogen there. So 3 is correct. As for whether all the carbon atoms are in the same plane or not, let me use a different color, green maybe. Okay, so that is in the same plane, So this is not planar, this is not planar, but the carbon and this carbon will be in the same plane. All right. What else is in the same plane? This is in the same plane, but this is no longer in the same plane. This is only in the same plane because they are part of this connected to this carbon double bond. But of course, this carbon is sp3 hybridized, so you need to be very careful. Same like this carbon is carbon sp3 hybrid. But that thing which is green, they are carbon in the same plane. So it's not planar here, but they are in the same plane. But this, and this, they already the single bond there, so they are no longer in the same plane as these, yeah? Only these 4 in the same plane. So the problem there is all. So really you're only left with 2 and 3 being correct. In this next question, what is the same, or what are the same, grammar, a pair of optical isomers? So you know a pair of optical isomers are the non-superimposable mirror images. So they are mirror images of each other, just like your left hand and your right hand, but they do not superimpose on each other. So I mean, I can give you an example. Something like an amino acid, which you don't really do amino acid here in AS. I guess you should know if you have something which are mirror images of each other, which are non-superimposable. When you have a chiral carbon, a carbon bonded to 4 different groups, okay, they will have the same functional group because they are the exact same molecule, except that they are mirror images. They will have the same empirical formula because they are the exact same molecule, okay. They are also have the same structural formula because they are not structural isomer, okay. They are not structural isomers. They are what you call stereo isomers. Okay, the empirical formula and the functional group are exactly the same because they are exactly the same molecule. It's just that they are mirror images of each other. Okay, so their molecular formula, their empirical formula is the same. Their structural formula is the same as well. It's their arrangement in space, they are different. Okay, so all 3 are correct. Next question. So you have this compound used as a flame retardant. So this is a bromoalkane. You will touch more on halogenalkane when you reach, I think, 10.4 or 10.5. Doesn't matter, it's one of those. Very easy to spot whether it's halogenalkane topic or not, yeah? Well, if you know your AS. Which statements are correct? They talk about molecular formula. This is defined as the actual number of atoms in one single molecule. So this is a skeletal formula. If you can't read skeletal formula, you have a big problem here. All right. The most important thing in skeletal formula is you must think carbon form 4 bond, carbon form 4 bond, carbon form 4 bond. All right. You don't show the hydrogen bonded to carbon in skeletal formula. So carbon form 4 bond, there's 1 hydrogen there. Carbon form 4 bond, there's 2 hydrogen there because the carbon is bonded to 2 other carbon. Carbon form 4 bond, there's 2 hydrogen. Carbon form 4 bond, there's already 3 bonds shown. There's 1 hydrogen which is not shown. All right. So I guess the number of carbon is the easy one to spot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 carbon is no problem, alright? How about the hydrogen? The hydrogen is probably the one that they will mess out a lot of students, yeah? I have 1 hydrogen. Okay, I use color, okay? Color. This is 1, 2, 3, 4, 5, 6. There is 6 hydrogen there, okay? I use a different color. 6 hydrogen, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 18 and then I have 6 PR, okay? Guess what? I have 18 hydrogen because there's 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17, 18. It's 18 hydrogen. It's not 20 hydrogen. Number 2 is wrong. That means only 1 is correct, because if number 2 is wrong, there can only be 1. Each brominated carbon atom is chiral. So they're saying each of the green color carbon is chiral, and that is true because there's a bromine, there's a hydrogen, there's this part of the molecule which is different from the other part of the molecule, right? So 1 is actually correct, well, by logic of 2 being wrong, but also because you know about chiral center, alright? Of course, the carbon-carbon-carbon bond angles are not all 120 degree. There is no carbon-carbon double bond at all. All the carbon here is carbon sp3 with 4 bond pair and 0 lone pair repel equally. So what you get is, well, the 4 bond pair repel equally. What you get is a tetrahedral 109.5 degree, or you could say it's 109 degree. All right. This is the last question of this introductory organic chemistry topical MCQs, section B kind of question. And it is the exact same, oh, well, hang on, it is not the exact same question. It is the exact same molecule with the same background information, with the same question asking for correct statement, but it is not exactly the same option. Okay, be careful, yeah? Here, they want empirical formula. Just now was molecular formula. Again, I will check number 2 first, alright? The C12 ring, so they're saying there are 12 carbon, as we did earlier. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The 12 carbon is not planar. That is true, because earlier I said all the carbon there is sp3, right? Okay, where you have the carbon bonded to 1, 2, 3, and there's 1 hydrogen. The carbon is bonded to 2 hydrogen and 1 carbon and another carbon. So all the carbon is sp3 with 4 bond pair and 0 lone pair. So they give you 109 degree or 109.5 degree in a tetrahedral geometry. That is not just on 1 carbon, that is on each and every of these carbon. There's no carbon-carbon double bond at all. So it is not planar at all. All the carbon are tetrahedral. That is correct. The empirical formula, you see, a bit tricky. Previously they asked molecular formula, so you can watch the previous question, but maybe I guess I'll work them out again. All right. So the molecular formula, which is defined as the actual number of atoms in one molecule. Okay, so there are 12 carbon, as I just worked out just now. But now I'm going to work out the hydrogen. These are skeletal formula. They don't show the hydrogen bonded to carbon. Carbon form 4 bond. You got to remember that carbon form 4 bond. Alright? Maximum 4 covalent bond. The carbon that is bonded to 1, 2, and 3, there is 1 hydrogen. The carbon that is bonded to 1, 2, and 3, there are 1 hydrogen. The carbon that is bonded to 1 and 2, there is 2 hydrogen. Alright? So if I put down blue as 1 hydrogen, okay? So blue is 1 hydrogen. And if I choose another color, pink, 2 hydrogen, 2 hydrogen, 2 hydrogen, 2 hydrogen, 2 and 2. So 2 hydrogen. So if you do that, you get 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17, 18, which is what I've done in the previous question actually. But anyway, if you skip straight to this question, you wouldn't have covered this. All right. So empirical formula is defined as the simplest ratio of atoms in the compound. Alright, so the simplest ratio is divided by 6 throughout, and you will get C2H3Br Yep, C2H3Br, C2H3Br, so 1 is correct, okay? There are 6 chiral carbon atoms. There is the chiral atom. The chiral atom is actually on the carbon with the bromine. Each of the carbon with the bromine is chiral. So each of the blue colored carbon is actually chiral. So you have 6 chiral carbon. I hope you can appreciate that if you are here, this side of the molecule is different from this side. Alright, and therefore, and there's also hydrogen. So each carbon there is always bonded to 4 different groups. So all 3 are correct. So this marks the end of this 5-question series on this section B type of MCQs on topic 10.1, which is Introductory Organic Chemistry. If that was useful, check out the other topical multiple choice question playlist on the channel before you do the full paper tutorial, which are also available. Yeah, share the channel widely with friends, your class group chat, your juniors, your seniors from school, anyone else you think this channel might be useful for. Alright, thank you for watching, thank you for sharing.